Let's see here. I feel like we started reflections. Okay. X minus 5 minus. Yep. Okay. Because I knew we didn't get to vertical stretch, vertical shrink yet. Now, I believe I made the statement yesterday that we weren't going to touch on horizontal stretch and shrink. Did I say that yesterday?
Yes, sir, you did.
Okay. We are actually going to do it in here. We are going to do it. Now, the reason I changed that wasn't because I'm like, okay, let's just do it. The more I actually thought about it, it's not that it's overly complicated or overly difficult. Y'all can do it. But the real reason that I changed my mind on that is because as a teacher, I'm here to help y'all learn and grow as students and individuals and become better. And I realized with saying that and what I said was not doing that, was actually more putting a cap on what you can do and putting that mental block, saying I can't do this. I don't think that's right, and I'm going to take that back. Okay? And the 2 hours that have done this already, like, well, the horizontal stretch and shrink was actually easier than what we were going to do anyways. The vertical stretch and shrink. So, turns out I was wrong anyways. So, it just creates one little hurdle that we have to keep straight. And once we get that, it's not that bad. Looking at it and deciphering it can be challenging, but we won't actually cover that because we're just applying these. Because the last chapter was actually seeing how does it affect, how does it move, how does it change, which we didn't do. But before we get to that, let's do at least one more of each, x-axis and y-axis, with reflections, and then we'll get there. So when we look at this here with the reflections, here, when we reflect it across the x-axis, we are going to be using our, so h of x is equal to, because x-axis is our negative f of x. Because the reflection across the x-axis is our y equals negative x. Let's record. So y equals negative f of x. That is our reflection across the x-axis. Well, now we just need to replace f of x with its function. The absolute value of x minus 5 minus 4. And well, the only other thing we need to do now is to distribute the negative sign to both the absolute value and the 4. And when we do that, we'll get negative absolute value of x minus 5. And then negative times a negative gives us a positive, and we get plus 4. And that's all we have to do for this here. Any questions on this here? We good with this one here? Okay. Let's look at this one here. We want to write a function g whose graph is a reflection in the y-axis of the graph f. So we're looking at g of x is equal to, well, a reflection in the y-axis is our f of negative x. F of negative x. So this time, we don't just replace f of x because we don't have f of x anymore. We have f of negative x. So that means we're going to replace every x that's in the function f of x with a negative x. So we'll have absolute value of negative x minus 5 minus 4. Well, there's nothing outside the parentheses. We don't have 2 times negative x in parentheses. It's just negative x. Since nothing is around this x in parentheses, we can just leave it as negative x minus 5 minus 4. We can just drop those parentheses. And that gives us our function g of x. And that's it. We're done. Any questions on this here? Are we good with this here? Awesome. So if we feel comfortable with the reflections in the x and y axis, we'll go on and move to the horizontal stretch and shrink and vertical stretch and shrink. Now you already have this all written out. I'm not making you write this out, so because that'd be a lot to write. But one of the key things is here are these two here. For horizontal stretch or shrink, we have it in the form y equals f of a times x, where our a times x is inside the parentheses. Now, vertical stretch or shrink, it's y equals a times f of x. Now, with vertical stretch or shrink, it's going to be exactly what it is. If they say it's a vertical stretch at 2, it's just going to be 2 times the function. If it's a vertical shrink of 1/4, it's going to be 1/4 times the function f of x, or g of x, or whatever it is. Now, with horizontal stretch or shrink, this is where we need to be a little careful, because it's a stretch by a factor of 1 over a. So whatever value they give us, we have to take the reciprocal of it. So if this horizontal stretch or shrink is by a factor of 1/2, 1 over 2, what we're actually going to plug in the function is not 1 over 2, but we have to flip it, and 1/2 becomes what? 2 over 1, which is just 2. So we plug in for the value of a inside the parentheses as 2 instead of 1/2. Then on the other side, if they tell us that the scale for the horizontal stretch or shrink is 2, what we plug in is not 2, but 1/2. We flip it. So it's almost, again, it's still following along the same lines of what we said earlier. Whatever's inside the parentheses is kind of the opposite of what we think. So with stretch and shrink, with vertical stretch and shrink, it's exactly what we think. With here, because again, we said if a is greater than 1, it's a stretch. Opposite of what do we think? If it's greater than 1, it means it has to be a shrink since it's inside those parentheses. So we make it into a fraction. Flip it. Well, inside the parentheses, if it looks like it should be a shrink, it's between 0 and 1. Okay, it's actually a stretch. We have to flip it. And that's really the only real hurdle with this. When we see horizontal stretch or shrink, we've got to flip it. We've got to flip it when we plug it in. And that's it. So let's look at these here. Now the first one will be a vertical stretch. Now the second one will be a horizontal stretch or shrink. We'll have to fix the vocab or the note sheets to make that work, and we'll get that in a minute. But let's look at this first one here. Write a function h whose graph is a vertical stretch of the graph f by a factor of 2. So what we're saying is that h, well, I don't want to write in a highlighter. H of x is equal to So our vertical stretch, as we defined it in the general form, was a times f of x. So for this here, it's a times f of x. Well, what is our factor? What are we going to replace a with? Yeah, 2. So it'd be 2 times f of x. Now, what is the function f of x? U3 minus 5. And this whole thing is in parentheses. But we need to distribute the 2 to multiply by everything that's a part of the function inside the parentheses. So we'll multiply 2 by the absolute values, which will give us 2 times the absolute value of x minus 3. And 2 times negative 5 would be negative 10. And that is h of x. And that's all we have to do on this here. Not too bad. All of these so far that we've gone have been pretty, each one's been pretty easy each step. Yes. If not, there's nothing wrong. Are we good with this here? Okay. Now this one here, you'll have to change your note sheets because it does say vertical. Just mark it out and put horizontal. Because the reason that vertical looks out of place anyways was because I manually put it in there. So let's look at this here. We want to write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. So what we're saying is g of x is equal to f of a times x. Because our horizontal stretch or shrink, our a times x is inside the parentheses. We're changing the input. What's going into the function? So what would be the value of a that we plug into those parentheses? Because again, we have to flip it. With horizontal stretch or shrink, we have to flip it. That's why it's tricky. We just need to remember to flip it for horizontal. Horizontal, we have to flip. 2, 3. And that's the big hurdle. Now that we have this, we can plug it into the function because we don't have f of x anymore. We have f of 3x. So anywhere that there's an x in f of x, we're replacing with 3x. So what we'd have is the absolute value of 3x minus 3 minus 5. So since it was just x, it wasn't 2x or negative x, we can really just drop those parentheses because it's not going to change anything. 3x minus 3 minus 5. That's it. Well, if there were like terms, we would combine them. Now, it's tempting to say because of the negative 3 and 5, I think is where you were looking at combining those. But because of those absolute value bars, it kind of stays where it's at. Was this easier than vertical stretch or shrink? I mean, we didn't have to distribute. We didn't have to worry about multiplying through. It's just replacing that one part. So that there's it. Because once we get past that, it's not that bad. It's just that one step of making sure to remember to flip it for horizontal. And that's it. Any questions on this here? All right. Well, let's look at another one. this one here. So again, in your notes, it's probably going to say vertical stretch of the graph, but we're going to do horizontal instead.
So you gotta flip it?
Yep, so we'll have to flip the value. So write a function g whose graph is a horizontal stretch of the graph f by a factor of 5. So we're still using g of x is equal to f of a times x. And just like before, our value of a, now they gave us 5, but we're not going to plug 5 in for a. We're plugging in 1/5. 1/5. Because again, since it's horizontal stretch or shrink, we have to flip it. We have to take the reciprocal of it.
How is that the flip?
So really 5, it's not written that way, but it's understood to be 5/1. And then all we need to do is replace the x in our f of x. Yep, plug it in. And we get the absolute value of 1/5 x minus 1 plus 2. Which is really just the absolute value of 1/5 x minus 1 plus 2. And that's it. Any questions on this here? Okay, that's fine. Let's do one more with vertical stretch or shrink, so we've kind of seen both. And then there's one last type we're going to look at. Write a function, h of x, whose graph is a vertical shrink of the graph of f by a factor of 0.25. It would not. Because this one is vertical. Vertical doesn't change. We don't have to change it for vertical, but we do have to change it for horizontal. And the big thing to remember if you're trying, especially if you're trying to keep it straight, is where it takes place. Because if you've noticed, whenever we're inside the parentheses with these changes that we did yesterday with left and right, because we plugged it in, it was a left movement, so it was negative. But what we ended up plugging into the function was positive, because it changed the sign. Just like with horizontal stretch and shrink, it's the numbers going inside those parentheses, so we end up changing it. But for this here, this stretch or shrink, it is on the outside, because we have a times f of x, because that is our vertical stretch or shrink. And the value a for this here is 0.25. Well, now we just need to replace f of x with its function, which will be our absolute value of x minus 1 plus 2. Then we need to distribute the 0.25, which will give us 0.25 times the absolute value of x minus 1. And then we have to take 0.25 times 2, which would be 0.5. And that's it. That's all we have to do for this here. Questions on this here? So a lot of what we've done yesterday and today is utilizing these y equals forms. If these are helpful, I think some of them, y'all find these helpful, writing these out first, do that. Do that so that y'all can kind of keep track of which one we're doing. And even if you need to have it especially out when you're working on the homework, have those written down. Horizontal translation, movement left or right. Vertical translation, left or up and down. Reflection across the x, reflection across the y. Horizontal stretch and shrink, vertical stretch and shrink. Having those written out, that's perfectly fine. Because again, when you take the test, you can write those out on the vote or on the review sheet to have access to. I am not going to make y'all memorize these. When are y'all going to use these after this? Yeah. Yeah. No, but the big thing is with a lot of this is it's helping you with your problem solving skills. Because the better you can problem solve, the better you are overall. That's a lot of what mathematics is. How can I solve the problems? So, unless y'all want to look at one of those two in particular, needing to see another example of vertical stretch or shrink or horizontal stretch or shrink, we'll move on to this here. Because I think y'all feel comfortable with this, at least with me up here. The last thing we have is combining transformations. So we can use more than one. Because what we've done so far is just a single one. We've done one of them, but that's it. Now, when we talk about combining transformations, it's not that we're going to use them all at once. What we will do for this is use them one at a time. Do them one step at a time. Because as we saw with like vertical stretch or shrink, that factor of A, whatever we stretched or shrunk the function, affected every single part of the function. It affected the absolute values and the number we added or subtracted from it. It affects everything. So we're not going to try to do this all at once. We'll do it one step at a time. So here, let the graph of G be a vertical shrink by a factor of 0.25, followed by a translation 3 units up of the graph f of x equals x. Write a rule for G. Let's do this one at a time. So the first thing it said, careful, was a vertical shrink by a factor of 0.25. So we're going to do that transformation first, and then we'll do the vertical translation of 3 units up to get to the graph G. So in the meantime, I'm just going to call this first transformation h of x, just to give it a name so we can reference it. For our vertical shrink, this will be a times f of x. So when we see vertical stretch or shrink, it's our a times f of x, a times the function. Now for this here, the value of a is 0.25. Well, what is our function f of x? It is x. F of x equals x. So we have 0.25 x. So this is our h of x. Now, I know it didn't say h of x anywhere in the problem, but I just picked one so that we can name it to when we do our next movement, we have a way to kind of identify it. Any questions on our first translation or transformation? Okay. Our next transformation is a translation of 3 units up. So for our g of x, what we're saying is, will you be using h of x plus k? Because before we would just use f of x, but since our new function is h of x, we're taking it and moving it up or down. Here we're moving it up 3. So really what we're saying is that I have h of x plus 3 because we're moving it 3 units up. Yes. And that's it. So really what we did is we took from what we've been doing the last few days and just did one of them once, and then took the new function and did another one to it. And that's all we would do, is we just take it one step at a time. Doing multiple of these at a time may work for some, but may not work for others. Okay? How do we feel about this here? You feel okay with this? Okay. I'm going to do one more. I'm going to redo this one here because I want to make a point. I'm going to flip the two moves because here it said vertical stretch and then translation up. Let's do it the other way. I'm going to move it up first. I'm going to say I'm taking this and saying f of x plus rk. So I'm going to move it up first. Well, since we're moving it up 3, it's going to be f of x plus 3 because we're moving it up. Well, f of x is just x. So we just have x plus 3. Yes? So that would be our h of x. Vertical shrink would be next, so that'd be our a times h of x. And our a is 0.25 h of x. Well, and again, just like we did earlier, we can replace h of x with x plus 3, because that's what it is. And now we need to distribute. Equals 0.25 x. And that's what we had when we did it the other way, yes? What do I need to do next? 0.25 times 3 is going to be plus 0.75. Did that give me the same function? Well, no, because it was 0.25x plus 3. They are similar to each other. It's just that this one here is 2.25 units lower down on the graph. Its graph is 2.25 lower. But as y'all can see here, it gave us two different functions in the order in which we do it. Now, for some translations, if we just moved it up, down, left, or right, there's a good chance it won't really affect it which order we do it. But especially with vertical stretch or shrink, or especially if we have a horizontal stretch or shrink, and then a horizontal translation left or right, will change, because if I have a horizontal translation left or right and then a horizontal stretch or shrink, will affect what the numbers are. Those two can affect each other. These two can affect each other and how they work. So the order of which it matters. But if we take it one step at a time, like we did here, it doesn't matter if we're trying to make sure we keep it in the correct order and how they affect each other. Because if we're taking it one of these steps at a time, it's going to take care of itself. We don't even have to worry about it, if it's going to affect it or if it's not. Because doing this as we did, just taking one part and then taking the next and the next, will work out just fine. We won't have to worry about, did I make sure that the vertical stretch affected every part, because I did it in the correct order. Can you all see how that works? Okay. Any other questions on this? Now I can say this, because here we did 2, the others examples we did 2, but we can have up to 6. Because we can move a function up and down, we can move it left and right, we can have a vertical stretch, a horizontal shrink, and a reflection in the x and the y. We can have all 6. It is possible to have all 6. But this book mainly focuses on 2, and I think the homework mainly focuses on 2. You're not going to do more than that, maybe 3. I might throw that in on the review sheet to do all 6. just to see, can you do all 6? And hey, I might throw it in as a bonus question to do all 6. But that's it. And that's the assignment there.